All right, let's get started on topic 3 practice test, going over these questions. Question 1 says, which relation is a function? So remembering a function means every domain has exactly one range. I'm just going to start drawing these pictures out and see what I get. So in number 1, I see my domains are 1, 3. Oh, 1 is repeated, 3 is repeated, 1 is repeated. So I only need to write them once. Over here, my range is 0, 1, and 3. And then I'm going to start drawing arrows. So 1 goes to 0, 3 goes to 0. So far, so good. 1 goes to 1. At this point, I can stop because one domain is going to two different ranges. I know A does not work. When I look at B, I can start again with my ranges or domains of 1, 2, 3, 4, and 5. I'm going to make it a little bigger there, 5. And then my ranges of 1, 2, 3, 4, and 8. So 1 goes to 1, 2 goes to 2, 3 goes to 3, 4 goes to 4, 5 goes to 8. B would be considered a function. I'm not sure if this is a select all that applies, so I'm going to go ahead and check the others. So C, my domains are 2, 6, 4, 3, and I see a repeated 2, so I don't need to write that again. 7, 5, 4, 3, and 1 are my ranges. So 2 goes to 7, 6 goes to 5, 4 to 4, 3 to 3, and 2 also goes to 1. So again, 2 makes that one not a function. Finally, D, it looks like my domains are 9, 4, and 0. My ranges are -3, 3, -2, 2, and 0. 9 goes to -3, and 9 also goes to 3, so I can stop right there, knowing that that one is not a function. Number 2, we've kind of already talked about this in number 1, but identify the domain. The domain are the x values, so it's going to be the set of numbers 2, 8, 30, and 46. The range are the y values, and so in this case, it would be -1, 9, and 16. Number 3 says Jack works after school. Each day he earns a set amount plus an hourly wage. Write a linear function that Jack can use to determine his pay. So the first thing I need to do if it's asking me to write a linear function is make sure this table is linear. So I'm going to look at the changes in y's. So 18 to 23 is an addition of 5. 23 to 28 is an addition of 5. 28 to 33 is an addition of 5. And 33 to 38 is an addition of 5. This all looks great, but remember, we need to know the whole slope, not just the change in y's. So change in x's is also a 0.5, a raise of 0.5, a raise of 0.5, and finally a raise of 0.5. So since they're all the same, I'm going to find my slope by taking the change in y divided by x. And so in this case, it's going to be 5 divided by 0.5. And 5 divided by 0.5 turns out to be 10. And so my slope is 10. Now that I know slope, I'm going to pick a point. I'm just going to choose the first one here and use point slope form. So y minus 18 is equal to 10 times x minus 1. We want this in slope-intercept form for the linear function, so I'm going to go ahead and do the 2 extra steps by distributing and getting 10x minus 10, and then adding 18 to each side. I end up with y is equal to 10x plus 8. So in function form, that would be f of x is equal to 10x plus 8. In this case, what that means is each day he's earning $10 per hour, and he starts with a set rate of $8. So using that in question 4, it says assume he works from 2:30 to 7. How much would he earn? Well, 2:30 to 7 is 2:30 to 3:30, 4:30, 5:30, 6:30 is 4.5 hours. So if it's 4.5 hours, all I'm going to do is plug that into this equation or find f of 4.5, which means I'm going to take 10 times 4.5 plus 8. 10 times 4.5 is 45. And 45 plus 8 is $53. Number 5 says write the first 4 terms of the sequence given this explicit form. And so what I'm going to do here is I'm going to find a sub 1, a sub 2, a sub 3, and a sub 4 because that n tells me what term it is. So that just means I'm replacing the n with a 1, replacing the n with a 2, replacing the n with a 3, and finally replacing the n with a 4. So 3 times 1 is 3, plus 6 is 9. 3 times 2 is 6, plus 6 is 12. 3 times 3 is 9, plus 6 is 15. And 3 times 4 is 12, plus 6 is 18. So my first 4 terms would be 9, 12, 15, and 18. And I can tell that this looks like a good sequence because each of those is raising by 3, and 3 happens to be my slope or common difference in this case. Number 6 is very similar, still looking for the first 4 terms of the sequence, but this time we're using a recursive rule. So remember, the now tells me the first term, so I'm starting at 21, and then to find the next term, it says take the now minus 2. So 21 minus 2 would be 19, and then 19 minus 2 would be 17, and then 17 minus 2 would be 15. So there are my first 4 terms. Number 7 says which of the following is an arithmetic sequence, meaning which sequence type is either adding or subtracting the same number over and over. And so I need to check those. And so from -2 to -5, it looks like I'm subtracting 3. From -5 to -8, I'm subtracting 3. -8 to -11, I'm subtracting 3. -11 to -14, I'm subtracting 3. And finally, I'm subtracting 3 one more time. So because those are all subtraction by 3, I will call that an arithmetic sequence. Now, again, I don't see select all that apply, but I'm going to just take a quick glance at the others to make sure there isn't another option. B, it looks like I'm adding 5 and then subtracting 5. And so right then I can say B is not an arithmetic sequence. C, it looks like I'm adding 2 and then adding 4. So again, C is not an arithmetic sequence. And finally, D, looks like I'm adding 6, adding 6. This one looks promising. Adding 6, adding 6. Oh, but look at that last one. They almost got us. It's adding 7. And so because it's not all the same, it would not be considered an arithmetic sequence. Number 8 says, if f of x equals 3x minus 3, find f of 4. So if you'll remember, I've replaced the x with a 4. So in my equation, I also need to replace the x with a 4. So 3 times 4 minus 3, and then it's just a problem to solve or to simplify. And so 3 times 4 is 12, and 12 minus 3 gives me an answer of 9. Number 9 says the table below shows the revenue in billions of dollars at theme parks in a certain country. Make a scatter plot of the date, and it tells you it wants it in year, comma, revenue. So I'm going to come down here to my x-axis and label those the years. So 1990, 92, 94, 96, 98, and 2000. And then I'm going to come over here on this side and label those. It looks like I'm just going to go by ones. So 1 billion, 2 billion, 3 billion, 4 billion, 5, 6, 7, 8, and 9. All right, so now I'm plotting at 1990. I was at 5.7, so almost up to that 6. At 92, I was at 6.3, so just a little bit above 6. At 94, I'm at 6.9, so nearly 7. At 96, I'm at 7.9, nearly 8. Doesn't want to make my point there. And at 98, I'm at 8.7, so nearly up here to 9. So that's a scatter plot, just plotting the points. Just do your best to be as accurate as you can in that. Question 10 then says, what type of correlation does that scatter plot show? And so when I look at that and I imagine drawing a line there, it would have a positive slope. So that tells me this is a positive correlation. 11 then says, draw a trend line and write the equation from that scatter plot. And so my trend line, remember, we want to draw a straight line and we want it to be go through as many dots or follow the dots as well as we can. And so in this case, I'm just going to go ahead and draw to the best of my ability. And then when it says write an equation, remember we need to find 2 points. So to me, it looks like mine follows here at 1998, 8.7. And maybe I also fit here at 1992, 6.3. So I'm going to come down here and write those 2 points down, 1992, 6.3, and it was 1998, 8.7. So now what I need to do if I'm going to write an equation is I first need to find the slope. So slope is y minus y divided by x minus x. Now, guys, you may not have the same points as I do, and that's totally fine. We're going to be checking your work, and so if your work is done correctly, then we may have some different answers, but they should be similar. So I got 2.4 on top, and then 1998 minus 1992 gives me a 6 on the bottom, and I'm going to go ahead and take 2.4 divided by 6, and I get an answer of 0.4. Now, I think you'll notice that this is even a different answer than shows on the answer key that was posted, and that's because my trend line is just a little bit different on this practice than it was on the last time I did it, and that's okay. All right, so at this point, now that I know my slope, now I'm going to choose one of those points and write my equation. So y minus 6.3 is equal to 0.4 times x minus 1992. Going those 2 extra steps to get it in slope-intercept form, I'm going to get 0.4x, and then 0.4 times 1992 is minus 796.8, and then y minus 6.3. I'm going to go ahead then and add the 6.3 over, and I'm going to get y is equal to 0.4x minus 790.5. Again, this answer is just a little bit different than the one that even shows on the answer key, but they're similar. They have similar y-intercepts and similar slopes. And so everyone could have a different answer on this one, and that's okay. So then using this information, predicting how much revenue the park will have in 2012, I'm just going to plug in 2012 for my x. So 0.4 times 2012 minus 790.5, and I'm going to solve. So 0.4 times 2012 minus 790.5. I get in this case an answer of 14.3. And if I come back to my graph, I'm just going to look and see if that seems reasonable. So 2012 would be out here a little ways, and yeah, that makes sense that it would be up here, probably around the 14. So then finally, I need to analyze what I've just talked about here. So what's true about that trend line? It says the slope is the revenue for 1 year. Don't think that that's necessarily true because the slope tells us the change in revenue divided by the change in years. The slope is the year. Well, the slope doesn't stand for the year. The y-intercept is the revenue for the initial year. That would seem to be acceptable there. And then the y-intercept is the revenue per year, not the case. But the y-intercept tells us where we begin. Finally, then, what R values suggest a weak positive. So a couple of words that I'm looking for there are positive and weak. Because it says positive, I can eliminate choices B and D. And then because it says weak, I remember that a strong correlation is close to 1 or -1. And so I'm looking for which one of these is closest to 1. That looks like C, that would be the strongest. So we would say A is a weak positive correlation. All right, I hope that helps, but please make sure you're contacting Mr. Jordan or Mrs. Sanders if you have any questions. We want you to do well, and so please take the time and effort it takes to prepare and be ready for your test. We'll talk to you later.